They are of the same shape and the same size. Therefore, they are congruent. The pages of this book are also of the same shape and size, so they are congruent too. The minute and hour hands of this clock are not of the same size. Therefore, they are not congruent. Since the shape of the hands is the same, we can say that the hands of this clock are similar. In other words, when two or more objects or geometrical figures have the same shape but differ in size, they are similar. Mathematically, we denote similarity with the similarities. These two buildings are identical because they have the same shape and size and are therefore congruent to each other. These buildings are not identical because they have different shapes and sizes and so are not congruent. How do engineers construct identical and non-identical buildings like these? They use models to build the huge structures. These models are of the same shape as the actual buildings, but their size obviously differs. In other words, their dimensions are scaled down. Thus, these models are not congruent to the actual buildings. But since they have the same shape as the actual buildings, they are similar to the actual structures. Are these polygons congruent or similar? We cannot be certain by just looking at them. Let's check if the shapes and sizes of these polygons are the same by measuring their angles and side lengths. First, we'll measure the angles in each polygon. The opposite angles in each polygon are equal. Now, let's measure the lengths of the sides in each polygon. In each polygon, the opposite sides are equal. Since the opposite angles and sides are equal in each polygon, we can say that both of them are parallelograms. In other words, both have the same shape. Observe that the corresponding side lengths and angle measures in both parallelograms are equal. Therefore, both parallelograms are of the same size. Since these parallelograms have the same shape and size, they are congruent. So we can say two polygons are congruent if their corresponding are equal. These two polygons do not look congruent. But are they similar? Let's check. We'll first measure the angles and lengths of the sides of the second polygon. Since the opposite angles and sides of the second polygon are equal, it is a parallelogram. So, both polygons have the same shape. According to the basic definition of similarity, two objects are similar if they have the same shape, but not necessarily to be of the same size. So, both parallelograms are similar. The corresponding angles in the two parallelograms have equal measures. Now, let's find the ratio of the corresponding side lengths of the two parallelograms. What do you observe? The lengths of the corresponding sides are in the same ratio or proportion. So, we can say two polygons are similar if their corresponding angles are equal, and their corresponding sides are in the same ratio or proportion. Based on these conditions, the two parallelograms are similar. What will happen if the ratio of the sides becomes 1? Ratio becomes 1, the corresponding sides will be equal, and hence the two parallelograms will be congruent. Therefore, all congruent polygons are similar because the ratio of their corresponding side lengths is the same.